Yeah. So, welcome to the meeting. Let's see. I don't know where Stefan or where Jesse is, but if he shows up, we'll start. Why don't we just ask first if anyone had any issues this week?
So basically, I move on to do simulation in the moving Braitenberg vehicle in the environment, and the learning result is a little bit worse than the static network, And I guess it is because I make the similar sources too dense, and there's going to be a lot of noise, and therefore learning results might be a little bit worse. Yeah. And I'm thinking about if there's any, anything I can do to improve this, like noise filter. I don't know.
Well, what is the? So you're using dynamic inputs. I'm not sure exactly what you mean. Like what you were trying this week.
Yeah. So I'm letting the Braitenberg vehicle to move in the environment and just let it learn when it's moving.
Yeah.
Mm-hmm.
And you're using that as an input. Is that
separate
from the sensory inputs, or is that integrated with the sensory inputs?
So what do you mean?
Well, I mean, you're just letting it drive around the environment. So you're just you're taking your model and you're adding motion to it, or is it just like movement based? I mean,
yeah, it's movement based. Okay. So I let the Braitenberg vehicle to approach the stimulus. I mean, I had 2,000 stimulus sources in the environment. I just let the Braitenberg vehicle to approach one, and when it's arrived at one source, it just go on and target another source, and I let it learn in that scenario.
And the performance wasn't very good, or it was worse than your other.
I let it to when there's no taste, I just let it to show up the predicted taste, and the predicted taste is like there's like a change, in the relative magnitude, but it doesn't really good.
Okay.
Yeah.
Yeah. Do you have anything to show, like any sort of graphs or?
Okay, not show any, really significant, but yeah, I was testing and just compare. I just print those out, and that's a message.
Oh yeah. What is your plan then for that? Are you gonna just kind of like not use that type of approach, or are you gonna like eventually do you think if you combined it with like some other form of using the senses and integrating them, do you think it would be a better result? I can't think of like how you might make the movement model better without doing that. I mean, you could filter for noise, or you could, use some sort of averaging, but I don't know. Beyond that, I don't really know.
Okay. I guess the density of the stimuli is also a factor that is affecting that sort of learning. So first, I guess I'm going to make this the environment I was testing on is kind of like it's dense. So I'm going to use a little bit more sparse environments, and then to see if it is a problem of the network or it is just the density. If it is a problem of the network, I mean, if it is the great, I mean, if the major problem is the network, that I'm going to find any improvement.
Yeah.
Maybe try to approach, or did you mention averaging?
Well, I think what I'm thinking is if you're training it, you want to have you want to have sort of a sparse environment, or you want to have something that's relatively controlled. So you don't want to have like 1,000 things in the environment. Maybe like 2 or 3, or maybe even like a binary distinction, or something very simple, and then you can because otherwise it's kind of hard to diagnose what the problem is, and it'll pick up a lot of things. There'll be a lot of false positives, for example, but then won't be able to tell like what it's hitting on, what it's not hitting.
Okay.
Yeah. So it sounds pretty good. Yeah. Well, try that and see what happens. Any other issues? What do you want to do in the next week or so?
Yeah. So firstly, just the test, the furthermore chaining and test I mentioned, and also the speed currently is good. I don't think I'm going to let it be Python. I just firstly use Python, then also I'm going to have the visualization parts maybe next week.
Okay. That sounds good. Well, I look forward to hearing about it. So, yeah, keep trying and keep working on it. So, Stefan, what is your what have your issues been for the last week?
Oh yeah. So you mean for the last week or for the week? You mean this week, by the way?
This past week.
Yeah. So basically, in the last week, I've managed that to finish the binary representation part of the code, and I've also, as I've written to you, this whole representation thing, and also this working with matrices and grammar approaches, it gets pretty complex. So what I do now is I'm trying to do end-to-end simulation as good as we could and as easy as we can, and then to be able to debug or maybe also evaluate. Also to evaluate our progress, how good are we, and what are the problems maybe with the easy components, and only then I would start to try to build in some more complex stuff.
Okay.
Yeah, so right now I'm going for that, just working with adjacency matrices, and I've already written a genetic algorithm. I said it wasn't that hard, because when you have this binary representation stuff, it's basically just a matter of a bunch of lines to do a simple genetic algorithm with 1 point crossover on this strings.
Yeah.
So what I've tested right now, we have a working simulation with working brains as they are. So I've tried to initialize random weights brains with 5 nodes, put them in vehicles and see whether vehicles would be able to process signal coming in with their brains and to give the output to the motors. And so this thing, I don't have any concrete metrics yet, so I don't do any plots or any brain information, because I would start it when we have, the whole picture, when we also have genetic algorithms and we can switch between epochs. I will start to produce plots and to really evaluate what is happening there. But at least one can say I've tested the networks as as a unit, and they're working. So they are doing their thing in some this way or that way. They're processing the signal, and they get the output. So they produce the output. Yeah. What the challenging part is, of course, as I've predicted, it's this binary representation of the networks. So yeah, basically, it's a bit problematic because Java doesn't provide any good and intuitive interface of working with bits, with bits or bit sequences. There is a class called bitset, and I'm currently working with it, but it's, I wouldn't say it's pretty intuitive. It's rather, it's a complex interface, and I guess the problem that I'm getting right now, there are some problems in extracting networks to the binary and constructing networks from the binary representation of them. And because the interface of this binary representations is not that intuitive, I'm getting some bug, and I'm working on it pretty a lot of time to debug this whole thing, this binary representation thing.
Yeah.
By the way, I wanted to mention on this point, like you've written in the evaluation, that we should maybe establish a weekly pull request. I wanted to make clear that I do create pull requests, but then I just merge them automatically all the time.
Oh, okay. Well.
So maybe if you look at the previous commits, for instance, I made a commit last week. It was just a pull request from me, and I've merged it, automatically because there weren't any conflicts, and I could do it.
Oh, okay.
But maybe if you like it more, I can also just create a pull request and leave it in, and you can look at the changes and then approve it yourself. It would be also fine with me.
Yeah, that might be, because I just want to see how, your progress is from week to week.
Yeah, okay.
Yeah.
So I will leave the pull requests then.
Okay.
Yeah. So yeah, as said, in the underline, there are some problems in binary representation, and there is some stuff, some minor bugs basically. I'm sure it's nothing that's groundbreaking. It's just something, maybe some arithmetic somewhere. So nothing serious. I just have to, find this point where it doesn't work good. Because of that, genetic algorithms do not work yet, so I have to fix binary representation first, but I've written the suite for the genetic algorithms. As soon as I get genetic algorithms to work and this binary representation is debugged, I will start to make plots which will help us evaluate the algorithm and assess its quality, what is happening there. And of course, also the problem with current binary representation is that I'm representing double numbers. Each weight is a double. And so double takes 64 bits in Java. And so if we have, say, five nodes in a network, and we have like 10 agents, we will have like 25 double numbers for each agent, for each adjacency matrix, which scales up to 64 bits for each 25 nodes, or maybe 25 positions in this adjacency matrix, and for, let's say, like 100 agents, and it comes up to 160,000 bits that we spend for that. And so, I'm I have the feeling that it won't be that scalable, what I'm doing right now.
Yeah.
There's, of course, some ways of doing it, maybe some representation magics, so I could create a low-level interface similar to double, but the one that would represent, that wouldn't have this big precision deep down in the weights or deep down in this floating point numbers, but less bits to be able to be represented. Not 64 bits, some lower amount that would scale up better.
Right.
And the second thing, of course, it's a problem with the distribution of weights, because what I'm doing right now, I'm saying that a random, so in the initialization step, I'm saying that all of the numbers between 0 and 1, I pick a random out of them. So we say kind of that they have the even representation, I guess. I don't know how random works, but the point is, what we would want to do is, of course, keep more zeros than any other numbers. So say, like, we don't have any connection between two nodes. It happens maybe relatively more often that we have any connection. And so the distribution of the weights, it would be looking like something like exponential with pretty big probability of 0. And I don't know yet how to do it in Java properly, so I should also figure this one.
Well, what is it like representing like lots of zeros and like a small number of other values?
Exactly. Yes. Because well, I guess this how it maybe happens in the real world, so that we much more often don't have any connection between nodes. So we don't have these ideal graphs where any node is connected with any other node, but we rather have really some forms, and we would expect many more places where two neurons are not connected at all,
right,
than even some weak connection. Yeah.
But you want to preserve the zeros.
Exactly.
Okay.
Yeah. So 0 in my paradigm, if you multiply something with 0, it comes 0 out. Right. So it means no connection, basically.
Right.
Mm-hmm. So yeah, I would say these two problems are highly technical. So it really boils down to the question: how do you implement binary representation, and how do you implement weights initialization? Yeah.
Yeah, I don't have an immediate answer for you on that, but I was thinking of like using sparse matrices, but that isn't really going to preserve zeros. I mean, there might be ways, of coding. Well, still wouldn't save you anything if you used you just use zeros, because it's one category, so it's like you're either throwing the zeros out or you're keeping them, and then that's basically what you have. And maybe I'll look and see if there's something like super obscure that might exist.
All right, yeah, sure. And I mean, I've also thought about sparse matrices, but more like in the context of scaling the whole thing. Right. So basically, sparse matrices could help. They could really help save some memory and some operative memory. Because I only have values down the diagonal in my paradigm. It's more that we avoid circuits, that our graphs are circuit free for sure. Because otherwise it would be infinite while, so to say. So we would pass 2 to 3, 3 to 1, and 1 to 2. It would be, we wouldn't end up with anything. Yeah. So basically, we have that more than the half of the positions in a matrix would be zeros for sure, because of this circuit-free constraint. And then sparse matrices, they make total sense in this case. Yeah.
Yeah.
But yeah.
Okay, that sounds good. What are your plans for this coming next few weeks?
So I would, there is a lot of stuff that could be implemented this way or that way. I'm picking some stuff just so it works, so it makes at least a bit of sense, and it pushes the project next. What I'm really following and what I really want to do is, as said, go from the very start to the very end, to the point where we have working simulation with genetic algorithm. this go that way. And we can also look and work with the simulation. Then when I have it, so I would basically finish up the genetic algorithms and switching epochs in the user interface. When I have this, I will start off coding some pop-up windows with various plots and various metrics in the next weeks or next week.
Right.
And then I will just evaluate how the algorithms work.
Yeah. All right. And then, so I actually I emailed Malin about at INCF about the travel grant, and I don't know if you got if I sent you anything back about that, but she said that there's a I guess it's like there's like one award per, like INCF has one award for everyone, and then they distribute it based on like some I don't remember what she said, but I don't think it's gonna work out. Like they have like one $500 award per mentoring organization, which is INCF. So it would be like competition amongst all the students in INCF.
Really?
Yeah, I asked her. I thought it was like per student, and she said, "No, that's not true." I don't know why. Because I mean, I've never had anyone request it. So I told her you're interested, though. I don't know.
Okay. Well, it's really strange because, as far as I know, they should give it really to students.
Yeah, I think like if you did something, but
could it be that's maybe? Well, I don't know, of course, but maybe Malin also didn't get the righteous information, or maybe it was. Of course, it was maybe the other way in the previous years.
Maybe, yeah.
Yeah, maybe.
I mean, I don't know. I just looked it up on the web. I just saw like where someone said there was something like a travel grant, but they didn't give any details. So.
Yeah, well.
Yeah. So I mean, yeah, I told her about it, and I don't know. They might, on the off chance that you get awarded the travel grant, you know, but I don't think the chances of that are very high. So.
I see.
Yeah. Sorry.
No, it's okay.
Okay. Yeah. All right. So let me check on this. Let's see. Okay. Just checking for Jesse on the off chance that he's still around. I don't know. He might have gotten cold feet or something. I haven't heard from him yet, so why don't we go on to the board? Let's see. Here it is. In the repo. Let me put this in the chat window. So here's our repository, as always. And if we go to the repository, and we go to the projects tab, and we go to group meetings review, we have some things here, done, in progress, and to do. So we'll go from done, we'll go to the left, as usual. Okay, so we haven't done, we have exchange proposals, get in touch with SimBrain developers, work on presentations, documentation with notebooks, set up presentation schedule, present papers, and set up programming environments. And then in progress we have number 4, share resources and implementation ideas. I think we're kind of doing that as we go along. I don't think there's anything new on that. Number 18, create Trello boards with tasks. So Stefan, that's for you. Is there anything in the Trello board I should be aware of?
Not something really special. It's just some issues.
Okay.
Come in and going away to them. So.
Okay.
Yeah.
Pick initial network type. I think that's done. I think both of you have kind of worked that out. Number 16. I'll move that to done. Find data set references for GitHub repository. That was me. I've been working on that. It's just like things that are like Connectome related data that people might be interested in. I'm not sure if I have anything in there right now. You might take a look. There's like in the code tab, there's like a folder, Connectome datasets. And I have a couple links in there, but I don't know. We haven't really gone through it yet. One time, if someone's interested, we might go through that a little bit more in depth. The OpenWorm, as I think I mentioned before, the OpenWorm Foundation has something called C302. So in the C. elegans, you have a full connectome available with all connections that are based on like gap junctions and electrical activity. So they actually have like something mapped out there. So if it's useful to you, you might look into that. So 17 conference funding, we discussed that. We'll put that in done for now. Research potential issue with building block method, number 13. That's for Stefan.
I'm sorry, which number once again?
13.
13. Yeah. I'm not going to use the building block method, not for now at least.
Okay, well we'll put that in maybe in done.
Yeah.
Yeah, I think you've got something good, what you're doing right now. So we'll see how that.
Thank you.
Yeah. So let's see. Number 23. This is now in the to-do column. Number 23. Visualization of networks.
Visualization. Yeah, right. So I'm thinking about, as said, first I want to work at this genetic algorithm stuff to be done. And then one of the metrics that I want to implement is, of course, also the visualization of the networks. And I have the strong feeling that there is some library out there, to visualize graphs. I would most probably just look for one that will work with Java or Kotlin maybe even, and use that one for this purpose.
Yeah. There are a couple I know of. I don't have the names off the top of my head. There are some that are sort of like Java and Python compliant. Nodejs, I think, is one. There are a couple of them to choose from. I know that, I don't know how suitable it would be for this particular application, but I think they're pretty general. So, because you have people trying to visualize all sorts of different types of graphs, so they have to be pretty general in the way they're set up. So, I think your options are pretty good in terms of what I actually might be able to put together a list of options here for Java and for Python, because just to save some time, because we've used them before in different projects, so you have some sense of how good they are.
Oh yeah.
Yeah. So, any thoughts on that, Ziyi?
The visualization of networks.
Yeah.
Yeah. Excuse me. Yeah, I'm thinking about visualizing a neural network, and also visualize the stimulus attributes of odors and taste, and also I'm thinking about making a column map for the environment and just visualize, have an animation of the Braitenberg vehicle moving in it, and also maybe show the trajectory of the movement.
Yeah, kind of like a hybrid visualization. where you have the network and then the movement in the vehicle.
Yeah.
Okay.
The panel for
Yeah. Yeah. Now, like something like Node.js would, it's a very general network visualization tool. It'll give you like the spaghetti map where you have like all the nodes and then all these connections. And, sometimes it's kind of hard to follow. But I don't know what beyond that, then you might be interested in creating visualization where you have, it may be like a person will be able to select certain types of connections. Sometimes, if you put some input data in where each connection has some attributes, so, they get sorted in visualization. So you say, I want to know what all connections related to some stimulus or connections that had a certain weight on them. And then it'll, show you those connections. So, and then, there's stuff like, even things like Blender where you can like build models in like 3D models, and then you can actually use like a graphic network plugin with that. And that's a little technically tricky, but there are options like that. So I'll actually look up and see what I can pull together in terms of a list for you guys, to evaluate. Because there are a lot of tools out there. So we'll keep that in. Actually, we'll put that in progress for now. Let me make a note on it and say like, open source. Okay. Update the comment. Okay, so yeah, we'll work on that. I'll work on that, and we'll talk about that next meeting more. Number 22, defining fitness function in the context of behavior.
Yeah, so it's basically also on the next list, and it's necessary to be able to finish the genetic algorithm stuff for me, because otherwise it makes little sense. A genetic algorithm, it should have any fitness function. And so my take on this point would be to analyze how far the vehicle has moved in the last several steps, I guess. So the idea I have right now is just to save, basically the wideness of the movement of the last, let's say, 3 or 5 steps of the in the just the process of the simulation, and then using this as a fitness for genetic algorithm. So the ones that will survive who have moved a lot in the last steps.
So it would be like an error function.
Sorry?
It would be an error function, or would it be like a? Because how would you evaluate the movement? Like.
Yeah, it would be a movement evaluation.
Okay.
Yeah.
So, yeah, that's something Ziyi might think about as well. Not necessarily a fitness function, but like maybe as a measure of error. So, like, if you have like a target and the thing moves towards the target or doesn't move towards the target, you might have an angular error whereby, if it's too much, it's a feedback signal and you're like, well, you need to move closer to the target. There's some relationship between the target and the actual movement. And so then you have to minimize that. But it doesn't know that until it does the movement, and then, you basically provide a feedback saying how accurate the agent was at moving towards the goal. And so in that case, it would be a little bit different than a fitness function. It might be something like just a feedback signal, like, move left or you're way off or something like that. I don't know how people implement them, but yeah.
That's a big one. Thanks.
Number 21, discuss relevant scientific questions. So that's sort of ongoing. We were just talking about like finding things that are like larger scientific questions that these things are applicable to. That, it's just something that's ongoing, I guess, maybe in the next couple weeks. Work on binary encoding, so that's actually something that's in progress. Correct? Number 19?
Yeah.
Okay.
And sorry, back to 21.
Okay.
What is exactly what scientific questions do we have in there included?
Let's see. Well, I think right now it's just a general issue, like what would be like, you think about like what we're doing here. What kinds of questions could we ask or answer, or what kind of scientific questions are like relevant to what we're doing? Like, what are the bigger issues, mainly? We get into the technical weeds with this project, but like, we can take a step back from that and say, what are we really addressing here?
Mm-hmm.
There's a lot of stuff on. Actually, that's very instructive if you look at the literature on Braitenberg Vehicles, because Braitenberg Vehicles, like the book, if you read the book, it's very sort of thought experiment, where he gives this thought experiment about these vehicles, and there's a lot of stuff on, emotions and about, learning and then, kind of gets down to where people are applying it, and they're applying it for like robotics, but it's, largely very utilitarian. I don't think people have really ever followed up, for example, on the emotional states part of the book. Or, when I had people writing proposals for this project, there are some people who brought up the emotional state stuff, like they wanted to tackle that aspect of it. And then, if you look in the literature, nobody really does that. Maybe that's, too far beyond like what people have been able to implement the systems for. But, there are all sorts of questions that, and again, like in the book, he's at the level of thought experiment for a lot of this stuff. So it's like, if we have simulations, though, we can like conceivably get at things. I think like Ziyi's project actually is bringing some, maybe like multi-sensory integration to the fore, because, he's taking like, he's dealing more with like different sensory systems. And so I don't think anyone's ever thought about exploring that before in the Braitenberg Vehicles. So.
Mm-hmm. Yeah, sure. Like I also find Ziyi's work to be really impressive. The topic, this integration, because it would be, of course, really cool to integrate, some movement stuff and at the same time some emotional stuff in these vehicles, and to do it as a multi-layer system which will take into account various inputs, so to say, and just investigate the interplay between them all.
Yeah.
But of course, one must say to this, the book Vehicles, it's really impressive and really cool one. But of course, when you implement this, you notice that thought experiments and real implementation of this thing, of the scientific concept, they are pretty far away from each other. So once you start to look at this problem from the point of implementing it and really defining the things that are there, you notice that you have to take care about this and that and other stuff, which changes the concept pretty much. So, for instance, I had to pick, I had to pick the way objects would really influence the sensors, and you have this question suddenly appearing, should the angle from which a object influences the sensor also be involved in the weights or maybe in the signal values that sensor would receive, or is it okay? I mean, do only the positions of sensor relative to an object matter and stuff like that. Yeah, so I would of course would like to also go for some scientific stuff, but let's see how much time does it take to implement that, because it's usually you undervalue the time it takes to implement something.
Oh yeah, of course. Yeah.
Yeah.
Do you have any thoughts
Yeah,
about
but-
this, Ziyi?
Mm-hmm.
Oh, well. Oh, yeah.
You're asking, sorry.
Oh, did you have any thoughts about this? Like, just how, are there any questions you've run up against? I know I sent you some stuff on, like, neurocoding and things like that, because they're kind of, tangential to what you're doing. But, do you think there's any, value in looking at the broader questions of what's going on in the brain?
Yes, yeah, and actually I was really, I firstly heard of the genetic algorithm from Stefan, and then I was in a library and I looked at a book called, yeah, it's just like the book about genetic algorithm, or what's it called? The algorithm that is like relating to fish and birds. I forgot the name of the algorithms. Yeah, and I'm thinking maybe after after down my currently simulation of Hebbian learning, and I'm going to try maybe genetic algorithm or anything related, and to see if there's going to be any discovery or say interesting stuff happening. Yeah.
Yeah. Yeah, genetic algorithms and like learning algorithms, they're kind of, I wouldn't say they're the same class of thing, but like they're very related to one another. I mean, there are a lot of connections that can be made, and people have even argued about using like fitness for behavioral aspects, and there's a whole like debate in the literature on whether that's appropriate or whether how appropriate it is to talk about behavior in terms of fitness relative to like genes and things like that, because there's been this dogma that genes have been the unit of selection in evolution, but other people say, well, no, that's not really true. Maybe there's multi-level selection, or maybe you can just say selection is on anything you want it to be. So I mean, there are a lot of issues with applying there, but there are a lot of parallels between genetic algorithms and learning algorithms. So, yeah, there is definitely a lot there to explore.
Yes, and for neurodevelopment, yes, I translated because I was in China. I am in China, and I was in a library about when I look at a book about genetic algorithm, and I found an algorithm called fish school algorithm. Is that the correct translation of it?
Yeah, I think so. Like schooling and flocking algorithms. Yeah, like that type of thing. Swarm intelligence, they sometimes call it.
Yeah. So for neurodevelopment, especially during the infant embryo, the neurons are actually were all together, and then they migrate based on affinity and based on a lot of factors, and then it becomes it's just like from a very chaotic cluster of neurons to a brain. And I guess I don't know. Yeah, it's just like some random thoughts.
Oh, well, yeah. It sounds there is this thing in swarm intelligence where, and people have done this with programming, where you have a bunch of agents and they're individuals, or they could be like neurons, people, and then they have these collective behaviors. So they have their own behaviors locally, Like,
Mhm.
there might be like a repulsion or like an attractant, and they have these relatively simple behaviors locally. Well, when they all do it at the same time or in parallel, you observe globally these like dynamic behaviors that you wouldn't expect. So like when you if you watch like a bird flock, they have these coordinated movements across the flock, and it's not all the birds aren't like practicing this thing. It's like they're doing things very simply locally, and then somehow that translates into the structure. So it's very exciting. I think some of the stuff that
Mhm.
people have done with like implementing that in programming.
Cool.
Yeah. So well, I think that's a good discussion about that. I encourage you guys to think more about that, and you know,
Mhm.
Jesse has been putting some readings in the Slack, like in the media section and some other channels. So I might re-up those in the Braitenberg Vehicles channel. He brought a paper on octopus intelligence. He put it in the Slack. So I'll re-up some of those too, because those will foster some maybe some questions on their own. So
Mhm.
let's see. So that's issue 21. Let's go through a couple more of the issues. We have a couple more left. Review components of model. This was Ziyi. This is like where you're talking about your model and you want to review components. So do you think that that's something you want to do in the near future, or is it like still kind of off?
Uh, I don't know.
Yeah. Well, I mean, I think when you feel comfortable, I just want to make sure that I keep asking you so that.
I don't know what kind of, um, what do you mean by review
Well, maybe in this
components?
case, like it would be like just doing like a formal demo. Like, we'll set some time aside at the meeting, or maybe 20 minutes, and then we'll kind of go
Mm-hmm.
through the model or part of the model that you want to present, like kind of like you did last week with the notebooks, where you showed your result. Except it'd be a little bit more like under the hood, maybe like you show, and then just us in the group here, uh,
Mm-hmm.
show kind of what it looks like, show some results, and then we can maybe discuss it a little bit and see if it's, I just want to give you that option. And I guess that would go for you too, Stefan.
Yes, probably. I'll make demo next week, and then we can discuss.
Okay, yeah, that would be good if we could do that next week. Um,
Mm.
and then, like 20 minutes, and it doesn't have to be slides. It can just be like, like a notebook, and then maybe some, if you have diagrams or if you have like equations, whatever, however you're kind of, maybe just code even, that's fine. Uh, and then the same goes for you too, Stefan. You can do that. I think if you want to show like a little bit of the genetic algorithm, or if it's something you want to get feedback on a
Mm-hmm.
little bit, because I mean, if we see the demo, if we see like how it kind of fits together, because I mean, you guys are describing it to me, and I'm like, yeah, okay. And I mean, I kind of get it, but it's like if I maybe see some more of a demo, then I can get it more, you know.
Oh yeah, yeah.
So what were you saying? Yeah.
So yes, I would be more than glad to do it, but as said first, I have to kind of finish this line, which would connect the whole things first, and then I can already start to plot something and to really show something. So what I could show right now, it would be just vehicles moving with their brains inside, moving across the world with um, with objects and so on, but I don't really have any visual infos right now,
Okay.
much more than their position, so to say. Yeah.
Well, yeah. I mean, yeah. When
Of
you feel
course,
comfortable.
I have code for that now. But I don't know. What if we would say I would show it in 2 weeks. Would
Yeah,
it be
that'd be
okay?
good. Yeah, we'll just put that as a
Because
tentative deadline. And,
exactly, because at this point in 2 weeks, I guess I would have more. Or maybe I can show like in next week and then in 2 weeks, and we will see how progress is if I'm moving in the right direction. So
well, we can do it in 2 weeks, and then like next week we can just like give an update on whether you think you can go. Because I'll give Z like 20 minutes, and then I'll say, Stefan, you think you can go next week, and then we'll just go from there. Because I mean, I don't want you to overthink it. Just put together like a short demo. Like if you were like someone asked you for a status report, and you said, okay, this is what I have. Just very casual, but also like showing the components in a screen share. That's all we need to do for that.
okay. So we would still say the next week, just present something.
Yeah.
Okay.
And I think the other 11 and 10, we'll skip those issues for now. I think those are kind of back off in the distance. Any other issues we want to talk about before we go? We need to create or...
Yeah. So basically, just adding to this conference funding issue.
Yeah.
So I've noticed that early birds registration deadline is tomorrow.
Yeah.
After that, they will cost €50 more the ticket. So I guess I would go ahead and register myself for the conference now.
Yeah.
And I just wanted to ask, maybe you have an idea, or maybe you have seen some grant suggestions from some other sources for the students, or maybe you have an idea where I could look to find them. Maybe there's some foundations that could provide such thing.
Yeah, they do have like occasionally. I think they're like professional organizations that have like travel grants. There's like I know bioinformatics. There's like the Bioinformatics Association, or I can't remember what their name is, but they have like a travel grant. If you type in like bioinformatics travel grant, or maybe like cognitive science travel grant, they might have like I don't know if you have to be a member of the organization, but they often have like small grants that you can use for travel if you apply, and then usually it's just like I want to go to this conference, and then give like a little rationale. I don't know of any off the top of my head, but I know there are some organizations that give like that have like travel grants of what would be like a couple €100.
Yeah, that's what I would maybe try to guess then.
Okay. Yeah.
Yeah.
Sorry, I couldn't help you out more, but.
No, it's okay.
Yeah.
Don't worry, no worries. It's just maybe we still win.
Yeah.
Die blessed. Yeah.
Yeah, it's always so hard to find like money for things like, and then they don't have like, and then they charge you a lot of money for like registration, and it's like I don't know, it's just really hard sometimes to make it. That's why I like now conferences are doing like remote presentations, so like they're trying to cut down on carbon expenditure for people traveling across the world. So they do, okay, well, you can do a presentation in your hometown, and we'll join you in progress, and that also cuts down on the registration fee. There are some conferences that do that now, so I think that's actually pretty good.
Yeah. Yeah, that's what this Braitenberg Global conference is doing, which I also really like. Have you heard about it?
No.
I guess it happens in May this year, and it's so just the global neuroscientist community. They do some presentation, and then they have sort of a Excel table where you can see all the topics of the presentation from various cities from all around the world, and also look the videos or watch the videos from the presentation, and it's pretty nice.
Yeah. Okay. Well, that's it then. If you guys have any issues, you can put them on the board or give me a Slack message if you need anything during the week. Otherwise, we'll meet next week and same time. Have a good week, everyone.
Right. Thank you. Have a good week.
Yeah, you too. Talk to you later.
Bye bye.
Bye.
Bye.